radicals, 2 or more radicals. What the heck? Okay, when multiplying radicals, 2 or more radicals may be multiplied together and placed inside the radical. Okay, so root 3 times root 5 is root 15. Root 7 times root 7 is root 49, which is 7. Now, you wouldn't actually do that. You would see a root times itself. It's like squaring a square root. What does it do? It undoes it, so you'd get directly 7. How about this one? Root 48. However, there is a perfect square. 12 is not a perfect square. Okay, 16. So this would be root 16 times what? 3? I'm doing it just like I showed you, right? 4 root 3. You like it better that way? Okay. 4 root 3 is my final answer. Okay, if numbers are outside or in front of the radical, I just want to make sure everything's still plugged in here. I just tripped on my... In front... If numbers are in front of the radical, they can be multiplied together. So, 2 root 3 times 3 root 3, the 2 and the 3 that are outside or in front get multiplied and I get 6. And then root 3 times root 3 can get multiplied. You could say it's root 9, but would I put root 9? I would not put root 3. I would put just a 3, and I would get 18. Next one. 3 times 2 is 6. Root 10 times root 15 is root 150, and there's got to be a perfect square that can come out of that. 25. So I'm going to rewrite this all beautifully like we just discovered we like. 25 times what? 6. You like it better that way? So the 25 will come out. It's a 5, and we're going to multiply it by this 6 that's outside, and we get 30 root 6 as my final answer. Very good. If radicals are within a binomial, they may be multiplied using the distributive property. The distributive property, grade 10. Actually, I think I'd talk about in grade 9 with my grade 9s. Okay, so what we're doing, what distributive property means, if you're taking something that's outside, you're going to distribute the multiply to both of those, right? So root 6 times root 2 is root, not root 8, root 12 plus root, not root 6. Root 6 times root 6 is root 36, which is just 6. But you should get in the habit, if you see a root times itself, it's just the number inside. Like, just go directly to that. It simplifies things. We can take out that one. What is a perfect square that goes into root 12? 4 times 3. So what do I get as my final answer? 2 root 3 plus 6. Can I add those together? No. It's like saying 2x plus 6. Can I add those two together? No, I can't. I'm going to give you a second to try B. Okay. So multiply both. So 2 times 3 is 6 root 12. 2, what is this if there is no number there? A 1. So 2 times 1 is 2 root 6. We can simplify this radical, right? So I'm going to show my work. 4 times 3. Okay, we can't do anything with the 6. So the 4 comes out as a, so it's going to be 12 root 3 minus 2 root 6. Is that what you got as your answer? Right on. Okay, moving on. To multiply binomial radicals, yes, we can use the FOIL like we did in algebra. So, do you want to try it now? do FOIL. Does everybody understand FOIL is basically just distributive property, but twice? Okay. Okay, so first I get 12 times 2. I saw a lot of people put root 4. I told you before, it's a lot easier if you can see root 2 times root 2 is just 2. Outer is minus 9 root 10. Inner, you get plus 16 root 10. And then last, you get minus 12 times 5. So then you get 24. You can combine those. So that is what? Plus 7 root 10 minus 60. And then last I can combine 24 subtract 60 and I get minus 36 plus 7 root 10. And that's my final answer. Did we get that? Okay, I'll keep going. Root 5 times root 5. 5. Outer. Minus 3 root 15. Inner. Plus 2 root 15. Last. Minus 6 times 3. So I get 5 minus root 15 minus 18. I combine those two together and minus 3 plus 2 gives me minus 1. And now I'm going to combine 5 minus 18 minus 13 subtract root 15. Yes? So the reason why I wrote for C, these are difference of squares. What's a property of difference of squares when you FOIL? What's a property when I multiply FOIL with difference in squares? The two middle terms will cancel, yes. So root 6 times 6 is 6. Outer, just for fun, I'll show you. Minus root 12. Plus root 12, does everybody see those two will cancel? That's the nice thing about difference of squares. And then last I'll get minus 2. So what do I get as my final answer? 4. Isn't that nice? Perfect square. Does everybody know what that means? That means it's self. So if you want, you can write it out to see the FOIL better, but really, there's a little trick that you learned in grade 9 or grade 10 when you FOIL this. It's the first squared and the last squared and then double the two, because you get two of the same thing, right? So if you don't understand that, then write it out and do it. So first you get 4 times 7. Outer you get plus 2 root 21. Inner you get plus 2 root 21. Do you see why I'm saying you get double when you have that perfect square? And then last you get plus 3. So here you're getting a 28. So what do I get as my final answer? 31 plus 4 root 21. Yes? Okay, so does everybody see this is a FOIL? I'm going to do the trick that I just showed you for the last one. I'm squaring the first, squaring the last, double the two multiplied together. So if I square this, what do I get? 9 times 3. If I square this, what do I get? Plus 1. Then I have to have double these two multiplied together. So what do I get there? 3 root 3. So double 3 root 3 would be 6 root 3. It's just a little shortcut. And then what does this minus mean with the brackets? That means it's going to distribute to both terms, right? So minus 5 root 3 minus 4. So I get 27 plus 1, subtract 4. What do I get? 24. And then 6 root 3 subtract 5 root 3 is 1 root 3 or just plus root 3. And that's my final answer. Are we good? Okay, so F, there's an F apparently. Okay, it's a FOIL again. So what do we get when we FOIL those together? That's a cube root now, right? So we're going to get 9 cube root 4W squared. Is everybody good with that? Outer, we get 18 cube root 2W. Yes? Inner, we get 5 cube root 2W. Yes? And then last, we get 10. So what is the only thing we can add together here? These two middle terms here. Can I simplify anything in this first term with the cube root? No, there's no perfect cubes in there at all, right? Remember, perfect cubes would be 1, 8, 27, and what would W have to be a perfect cube? At least a 3, right? Yeah. So 9 cube root 4W squared plus, what is 18 and 5? 23 cube root 2W plus 10. That's my final answer. You can only add or subtract. Sorry, multiply or divide is I think what I want. Because I already did the adding, subtracting the other day. You can only multiply or divide radicals if they have the same index. Dividing radicals. So when dividing radical, a radical may not be left in the denominator of a fraction. So we cannot leave we can't have a radical as a denominator is what I'm trying to say. So last year in grade 10 you learned that if you can actually divide, you can divide. So this is this that doesn't make sense. What I mean is if the 48 and the 6 divide, you can actually rewrite this as 48 divided by 6 and actually divide it. If you know how to divide, you can divide, and you get root 8, yes? And then that can be simplified to be 2 root 2. Exactly. So, I know, it's crazy. So, what about B? Can I divide 27 divided by 9? Yes. You can divide anything if you want. Does it work out nicely is another thing, right? Okay, so look at this. We can actually divide those. Do you need to actually write it out like I did A? If you know that property of radicals and division, just go ahead and do it. So what's 16 divided by 4? 4. What's 15 divided by 3? And it's in a radical, so root 5, right? Yeah. How about this one? This would be root 3, right? Okay, next one. 12 divided by 4, right? Yeah, so 6 divided by 3 is 2. Root 18 divided by 9 is root 2. Okay, I'm going to give you a second to try F. Okay, did you get the 3 would go on the, like that. It'd be 1/3, right, for this part? Yes? 1 over 3. And then what do you get here? Root 10 on top. So really this is just root 10 over 3, right? Okay.